Okay, everybody see, let's do this together. Okay. Okay. Can everybody see my screen? You guys can screenshot it. Can everybody see my screen? You guys can screenshot it. That is FA. Okay, screenshot ready. This is FA7. All got this, Okay. Now, when I want you guys, thank God, they put until here qualitative analysis notes. Okay, they put that under qualitative analysis notes. And then they say one cation, one anion. Can you tell me which one is it? What I'm trying to tell you is that what I'm trying to tell you is that based on the color of this, right, of this and this, right, before even starting the experiment, right, I already isolate out roughly where is it, right? Because they say the keyword they have is it is one cation, one anion listed in the qualitative analysis notes. So before I even start, right, I actually have a rough idea where is it around already one. Yeah. I hope you guys are like me, you guys will figure out it should be around with the colored compounds already one. It should be the colored compounds already. This area, because most of the cations, they are not colored. Make sense or not so far? So I already isolated out most likely either chromium, copper, iron 3+. Actually, one of them very evident already what cation it is, but we'll just continue on now. Okay. Now everybody got those two colors ready, a screenshot ready, right? Okay, now I'm going to do the first one. Add potassium iodide, Fa6. Okay, can all of you see this clearly? This is Fa6 add potassium iodide. Please write down your observation. This is Fa6 add potassium iodide. Please write down your observation. Everybody got an observation? Please give a thumbs up. Okay, good. Now let us move on to the next one. So after this, right, I added what? Potassium thiosulfate. So everybody got that on. This is what it looks like. Added potassium thiosulfate. Please write down your observation. Once you write down your observation, please give a thumbs up so I can move on. Okay, Fa7, add potassium iodide. Once done, give a thumbs up. Once you write down observation. Okay, I move on already. I add now thiosulfate. Later recording can go through it. Okay, screenshot it. After adding sodium thiosulfate. Yeah, adding excess sodium thiosulfate. This is what it looks like. Okay, just write down the observation for now only. The observation should be very crystal clear. Okay, can I move on? Next one. I don't have zinc powder. I use zinc granule, but the idea should be the same. Please create your observation right now. This is Fa6 with zinc powder. I use zinc granule because at the time I couldn't find a good powder, but the observation will be the same. Should be the same. Okay, everybody got this ready? Okay, hold on. This one a bit special. See clearly. Don't have the music, but you can see. Fa7 with zinc powder. Okay, let me play one more time again. Now, test for the gas lah. But I don't want to test for the gas. I want you guys to write down for me, what do you think the gas is? Tell me the observation from the expected gas. Tell me the observation from the expected gas. I added zinc powder to there. Suddenly, there's this lah. So you may say, so where's the test for the gas? I want you to tell me, what do you think the gas is? All get until this part already. Not thumbs up if you are until this part already. I want to show you silver nitrate and sodium hydroxide. Now, let me show you silver nitrate. Silver nitrate should be... sorry, this one a very ugly photo. This one. Okay, now, so this one is what happened when I add silver nitrate. Just to be more unclear on the top, I try to take from the top. This is silver nitrate. Sometimes it's a bit hard to see. So I add silver nitrate to this. This is what happens. Okay, this is silver nitrate with copper one. You know, sometimes you have to see the color of the precipitate, right? You know what I recommend you or not? I recommend you shake it. So why do you want to shake it? I shake it, right? Because the precipitate will stick to the wall. Sometimes when it's very hard to see inside the solution, right? I really shake it or shake it harder or have the precipitate stick to the wall, see the precipitate on the wall there. And sometimes you're lucky, right? The precipitate will float on the surface of the thing. That's one way to see it. Now, for silver nitrate with Fa7, it looks something like this. Okay. Now, you may say, sir, cannot tell lah. Cannot tell what color is the precipitate. Okay. Because the original solution a bit yellow color lah. So we have to tell what the color is with the precipitate, right? There are two ways to do it. One is try to, like I said, the previous method, have it stick it to the wall. Stick it to the wall, right? See the color on the wall. There's also another method. This one, I leave it to stay for 5 minutes. I leave it to sit on the test tube for 5 minutes. If you are lucky, right, what happens is that the precipitate goes down here. The precipitate goes down here, condenses, leaving the solution on top, enabling you to see the color of the precipitate clearer. So there are two techniques because I know one. The solution yellow, suddenly you put the precipitate inside there, don't know what color is the precipitate. Makes sense, understand. So there are two ways to do it. One is we shake it, right? Have the precipitate stick to the wall. The other we have the precipitate, let's sink to the bottom. Wait for 5 minutes. Let's sink to the bottom. Then now can see clearly already. Yeah. Okay, now Fa6 with sodium hydroxide. Whenever I do sodium hydroxide, this sort of thing, I always do it 1 drop first. This is 1 drop. Okay. After 1 drop, what happens? No shaking. Hand steady at 1 drop. Then afterwards, excess. Add a lot, then shake it. Become like this. Okay. Okay. All got this. Okay. Now, for FA7, get this, which one clearer? Okay, this one clearer. Add in 1 drop. That's the 1 drop right there. Okay, I add in 1 drop. The 1 drop turns out to be like this, a bit weird. Okay, FA7 sodium hydroxide. Then, after adding excess, becomes like this. Notice if I want to find out what color precipitate is, again, I shake it strongly, the precipitate will stick at the wall here. Sometimes you don't know what the color precipitate is. Shake it, you see the precipitate stick at the wall here. All these are precipitate solid. Can I now move on to, okay. Now let's look closely. This one, the bottom here, all of you got it correct. Just copy only. So for this one is pale blue precipitate form insoluble in excess. This one is red-brown precipitate. Follow exactly, sorry. So this one is red-brown precipitate, and then the other one is pale blue precipitate. Follow exactly. Okay, sorry. Pale blue PPT insoluble in excess. Red brown PPT form insoluble in excess. Okay, I hope all of you guys got this. White precipitate form. This one is actually also white precipitate form. Now, the reason why they allow what cream, pale yellow, or off-white, right, is because they scared that people cannot see. So sometimes they're a bit nicer. They allow more variants. Basically, this is talking about silver, bromide, and iodide. Sometimes they're not that kind. They allow white. So I'd rather you guys get the correct answer. It is white, because if you look at my picture, right, you see not white in color. It is white in color. Okay, next. This one, right, is zinc spatula is solution turns colorless and brown solid form, brown or black solid form. It is because your zinc, right, is supposed to be the gray color, right, suddenly become black in color. The black in color is because what's happening right here is that you're having metal displacement. What's the metal displacement there? You're having your copper 2 plus zinc forming copper, that's the brown solid or black solid, plus Zn2 plus. No more Cu2 plus, solution turns colorless. This one is effervescence formed gas pops with lighted splinter. Okay, now this is the tricky part. You must be wondering to yourself, iron 3 plus, how come will react with zinc? Turns out that iron 3 ions solution is a little acidic, just like aluminium solution. Okay. I know you guys may be confused. Sir, what is this? Why aluminium solution acidic? Aluminium chloride. Okay. In water, what's the pH? About 3 to 4, right? About 3 to 4. Okay, I'll call it 4, call it 3 also can. 3 to 4. You know what the actual, I think it's 3. If I'm not mistaken, I think 3. Okay, 3. Why is aluminum oxide as aluminum solution acidic? Because the aluminum 3+, right, has so high charge density that it forces the water to form a complex around it, correct or not? Al3+, ma. Remember this? That's why you go and form that aluminium complex with 6 molecule water, then finally it dissociates to give you 1 hydrogen ion. That's why acidic, ma. Same exact reasoning with iron 3+. A lot of charge, 3+. The ion relatively smaller, high charge density, iron 3 solution will be very acidic. It will be, the solution will have a little hydrogen ion. That hydrogen ion will react with the zinc powder. That's why effervescence form. So it's actually zinc will react with hydrogen ions to give you zinc 2+ and H2. Does that make sense? I can straight away tell it's a hydrogen ion because I straight away see the word zinc. It's a metal. When you have a metal added into that, and suddenly you see effervescence, right? It's metal reacting with acid to give you hydrogen gas. This one is brown solution form. What do you think is the brown color? I know they never explain one. This entire test one part, this test one part, I can honestly tell it's from A2. I can honestly tell it's from A2. Okay, especially this part. Brown solution form, right? It is because you have a redox reaction. Never mind. Let me write out the observation first. This one is brown solution form. This one is brown precipitate form. I hope you guys got that. And then this one, precipitate turn to white color. This one, brown precipitate turn to white color. This one is colorless solution form. Now, why is this a redox reaction? What happens right here? Let me put in red pen. It's because you have your Fe3+ reduces your oxidizes your I- to become I2 and Fe2+. So it's an oxidizing agent. It accepts the electrons from iodide to become iodine. The brown is the iodine. The brown color solution is the iodine. Of course, Fe2+ also got certain color but yeah, but it's a bit faint. Then, so why got color solution suddenly form like that one? Because, right, what happens is that your iodine will react with your thiosulfate S2O32- to give you iodide. To give back iodide and iodide and I think sulfate. Okay. Fa7 makes sense so far? Please give a thumbs up if it makes sense. Yeah. Okay, why got brown precipitate form? This one, right, is very annoying. It's because it's in A2, copper 2+. plus iodide will get reduced to copper 1 iodide and I2. Copper iodide is actually the precipitate. Iodine is actually forming the brown solution. So the reason the precipitated white color, actually your copper iodide is actually white color already one. You cannot see the white color because of the iodine inside the solution is blocking it, looking as if it's turning brown precipitate. So how come the precipitate white color leh? Because the brown color has already formed into iodide. So leaving up copper iodide, white precipitate once you added the sodium thiosulfate. That's why. This entire thing is what I call noise. They are just testing for your observation skills only. The one that really confirm the cation anion is actually these two. This one, this part here is more of noise. Does that make sense? Do you guys all before we go on, do you guys all get the same observation that I did? If you guys get all the same observation, you should get the full 5 marks. This one is absolutely separate already. Yeah, this 2 marks is based on observation skills. This halide testing, that one is based on barium chloride testing for cation anion test. Okay lah. This one is test for ammonium. If your sodium hydroxide and your ammonia doesn't work, you just test it with sodium hydroxide, heat it up with aluminium. And then the anion one, yeah, anion is just testing with the first barium chloride, barium nitrate, that sort of thing. I think quite relatively straightforward. The only one I want to go through is these guys only, because this particular is very tricky. Okay. I cannot go through every single one of them because there's too many weird stuff, but hopefully I go through many of them. So tomorrow if you see weird stuff a bit, right, just remember some of them is noise, some of them will lead you to the correct cation and anion test. Don't get confused. Don't say that you must try to explain everything. It doesn't work like that. Okay. So I hope what you guys have learned from all of them later, make sure to upload all of them, the question 4, MS and everything. This differentiate between noise and not noise. So for qualitative analysis, there should be no problem. For quantitative analysis, please refer back to the revision. I put the extra quantitative analysis mark scheme and questions and data.